We're going to continue our review for the final, but again, the one that we were using didn't go over some of the kinds of things you're going to have on the final. So I'm going back to just the chapter test. And again, showing you the kinds of things and the strategy needed to solve problems. So we did a little bit of chapter 6 already, but we'll do a little bit more now. So here we have a multiplication of a rational expression. And even though it's multiplication, it's actually more simplify, where we will use the principle of factoring. So let me factor this for you. So I've just taken this is straight, no changes. Here I'm going to factor a 2 out of each term. Now here I had to factor a 3 out first, and I got then the difference of perfect squares that factor into its conjugates. And now I look for common factors. This and this, this and this. So on the top, I'm left with a 2. And on the bottom, I'm left with a 3 times y minus 5. And this is the preferred way of leaving it. This, remember, is just an intermediate step from this to this to this. Okay, now in division of fractions, and this is critical because they didn't go over this in the other test, you have to take the reciprocal of this, which is just flipping them, and changing that to multiplication. So that's what I'll do over here. And I'll go through the process with you too. So as we look at this one, this is the difference, no, the sum of perfect cubes. So there's a recipe for that. This plus sign goes there. Opposite sign goes there. And this is a parenthesis for 2 terms, parenthesis for 3 terms. So this will be the cube root of that, which is x, cube root of that, which is 2. Square this, multiply these two together, square that. So that's the factoring of the sum of perfect cubes. Now this one is the difference of perfect squares, which will factor into its conjugates. Now remember, you could put this there or there, that's not a problem. Now I have to flip these. So this one now is going to be on top. So let's factor that over here. It's going to be an x and an x. 20 with a difference of 1 will be a 5 and a 4. And 1, let's see, the 5 will be negative, the 4 will be positive. And now we're going to factor this one, x, x, and then it's 5 and 2. And this will be negative, and this will be positive. And you can FOIL to check it. Now notice in chapter 6, just one problem is like 4 examples because you have to factor each one of these. And now you're looking for common factors that you can cancel out as a 1. This over itself is a 1. This over itself is a 1. This over itself is a 1. So your final answer then will be this over this. Okay? Now in finding the least common multiple, again, we factor. And we did one like this, and you factor out the greatest number of times that factor is used. That will give you that. So again, we're trying to keep this a little bit short and go over some of the major techniques though. So for, in this case, number 4, the denominators are the same, so you just put this over your common denominator. You can do a little factoring to simplify, do that. Now in number 5, here we see this denominator and this denominator are similar but have opposite signs. So how would you get a common denominator out of that? Let's say it's going to be a minus b. Well, in this term, if we factor out a -1, this then becomes a negative and this becomes a positive, and I can switch them around into this order. Now here I could make this a plus and I could make that a negative. And I have negative divided by a negative, so this just becomes all a positive. So now that you have a common denominator, it's just a matter of doing this. And this may factor, so let's see what we find here. Yeah, lots of stuff going on here. So when I grouped my top, I put it in this form, which is a perfect square trinomial, but I see I had a common 3 that I factored out of each term, and then there is the factorable form of your perfect square trinomial that factors into this. Now normally you would write it as this squared since there are 2 of them, but now I can just factor out one of them, so my final answer then is this. So a couple of things going on. When the signs are reversed, you can factor out a -1. In fact, let me clear this now. Factor out a -1, and you can just make this positive, and that becomes this over there. Then you just group this, put it in a form, factor it. All right, now number 6 is one that I did want to show you, and we're adding, but our denominators are not the same. So what would be our common denominator here? Well, this is the difference of perfect squares. This is one of its conjugates. So it's going to be x plus y, x minus y. So this one actually has both, so we don't change this one. But this one, to make it that, we have to FOIL it by the x minus y. Then we have to do our top then, x minus y. See, this is our 1 that we're multiplying this fraction by to make it an equivalent fraction. So let's do it up here. We have xy from this one already plus x squared minus xy. And notice we have an xy here and an xy there, and they subtract out. So then our final answer will just be x squared, because these just cancel out through subtraction, and we end up with that as our final answer. And I'll do this one too. So the first thing we'll look at is we have to factor this one here into this. And then now from this, pick out my least common denominator, which will be x plus 1. So we need an x plus 1. And that's used once there, used once there. But this is used once, so we need this. So our least common denominator will actually be this in its FOILed form. So what does this one need? Well, it's going to be a 3 times the one that's missing, which is this one here, x plus 3. And then now notice we can make this a plus, and then just change both of these signs. Make that a negative, make that a plus. So it's easier to deal with. So this becomes 3x plus 9. And then we said we had a negative x and a plus 2 there. Okay, so then we are going to group like terms. And I can do it right over here. We get 2x plus 11 all over that. Okay? In example 8, again, I believe these are the factors of this. So this is your lowest common denominator. This term would have to be multiplied by x plus 4. And this term would be multiplied by x minus 2. And keep in mind, this is a negative, so I'd make it plus, make this negative, and then this negative, and combine like terms. Here we have to remember to take the reciprocal of this and see what factors out and simplify. Okay, we didn't do complex fractions, but we did do equations. We had one just like this where you're going to cross multiply. Now in number 13, let me do that for you to show you the technique. Well, this is your denominator. These are fractions in an equation. We want to get rid of each of our fractions. So we multiply every term by the least common denominator, which happens to be this, and this is its factored form. So as you clear the fractions in the denominator, this will cancel with this completely. So you're just left here with t plus 5. Now this one, t minus 3, will cancel with this one. So you're just left with 1 times t plus 4. So t plus 4. And then on this side, the t plus 4 cancels, and you're left with a 3 times this, which is, see if I can do that. 3 times t is 3t. 3 times a negative 3 is a negative 9. So we group like terms. 2t plus 9 equals 3t minus 9. I transpose my 2t to this side. I end up with a t. Transpose this to this side. I end up with an 18. T is 18. Now, does 18 make any of my denominators a 0? No. So that's the answer. Okay. We didn't do division. And we did some work problems, and we did a distance problem, I think, too. So, again, that'll be our review of Chapter 6. Okay, now looking at Chapter 7, and again, we want to review techniques, some major things, strategy. Here, they're asking us to simplify this radical. In something like this, we want to see if there is a perfect square factor of 63, and it's 9 times 7 is 63, and then the square root of 9 is 3. Now, keep in mind that generally If under the radical sign and it's an even power, even index number, you can't have a negative here. But if the index number is odd, you are allowed to have a negative. So 8 is a perfect cube, and that will be 2. And taking our index number, dividing it into 9, we get x to the third. Now, this is a negative, well, it's not a negative, it's 100, which is a perfect square, so that would be 10. And this is a perfect square as well, just divide that by 2, and that would be that. Now, remember, it could have been a negative. Something like this squared would give you that too. So to protect ourselves when we do this, we often say plus or minus the square root of, or I should say, I get carried away with the radical sign, 10a. And then sometimes we put absolute values there, but I'm not going to be critical of that. Okay, let's go on. Now as we look here, this is a perfect square trinomial. I don't know if you recognize that or not, but this will factor into x plus 4, the quantity squared. And since we're taking the square root of that, that just becomes, when we take away the radical sign, x plus 4. And again, that one we would put in absolute values, but basically all I would be interested in is this. Okay, going on for a quick review, although this is going to be a little longer than I thought, because there's lots of examples, is convert this using exponential expression here with an exponent. We're going to convert it to a radical notation. Again, this is 6/5 here. So we use our radical sign. This is our base, which will become the radicand. Now, our index number is the denominator of the fraction. So the 5 goes there. And then we can put this in parentheses and raise it to the 6th power. And now for this one, we want to do the opposite. So we will take our radicand, which now becomes our base. And the exponent of all of this is 1. And our index number, when there isn't one written, is 2. So that's what we have. And for this one, to determine the domain, we just equate 12 minus 6x equals 0. So this has to be actually greater or equal to 0. So we take our negative 6x, put it over to this side, becomes a positive 6x, like so, and then we divide both sides by 6. So we then get x, which is this x, is less than or equal to 2. And what would be the domain of that? Well, if we made a graph of it, it would look like our 2 is what we're interested in. This is going to be a bracket facing left, and it would look like so. So to put that in interval notation, it's coming from negative infinity going up to 2, and that would be what our domain is. Again, I'm not sure what way they want you to show it. on your final will be multiple choice, so you have to pick the right one. That's how you do it. Okay. Here they just want us to square that. And I think we did something like that. Just going to put a square there. So we square the first term. This is 16. We multiply these two terms together. That gives us a negative 4, the square root of 2. Then we double it. Negative 8, the square root of 2. And then we square this, which will give us a negative times a negative will give us a positive. Square root of 2 times the square root of 2 is the square root of 4. And the square root of 4 is 2. So now we have two like terms. This becomes an 18 minus 8, the square root of 2. All right, again, on a final, you would only have one of these, and which one you have, we don't know. But what do you do to simplify these? Well, this one, for instance, is very straightforward, but this one's a little more of a challenge, because what we're asked to do is to see which of these are perfect cubes. Well, we have 32 is 8 times 4, and 8 is a perfect cube, so we put the 8 there and the 4 there. And then a to the third is a perfect cube, and what's left over is a to the second. And we have here b to the sixth, and we have a b left over. So under one radical sign, we put perfect cubes, and then whatever's left over is there. So this becomes 2a b to the second, and then we add that to it. This is going to be 3x 4y squared. And here, again, we're looking to simplify this, which is just multiplying it. And we get the third root of 3 times 6 is 18 x y to the second. So within 18, there are no perfect cubes. So that's all you do. Here we put all of this under a common radical sign and simplify. X to the second, x to the third leaves me with an x. Y to the third, and this is fifth root. Okay. Well, again, we're not going to be able to teach the whole course or review every single thing, but to give you an idea of how they work. Here we're combining like radicals. As long as the radical part is the same, we just add the coefficients that are in front. Here we would have to simplify to see what we get. Here we're foiling. Some of this we didn't have. Again, if we didn't have a section, we didn't do it. Okay. We didn't have to rationalize denominators that had two terms, but for those of you going on, we use the radical conjugate to do that. So this would be 7 opposite sign plus 2 the square root of 3, and 7 plus 2 the square root of 3. And here we would FOIL this. Here 7 times 7 is 49. And then since they're conjugates, there are no middle terms. So square root of 3, square root of 3 is square root of 9, which is 3. 2 times 2 is 4. 4 times 3 is 12. So this becomes a negative 12. So we just add this together, FOIL our top, and this will be our answer. Now for solving equations with radicals in it, you do have one of those on your tests. So the rule is you isolate the radical. by taking that 3 and bringing it to the other side. So we get x minus 3 equals this. Now to get rid of a radical sign, whatever index number is here, that's the power you raise it to. But you have to do it to both sides. So now you have a binomial that you're going to square, which gives you x squared. Multiply this, double it, negative 6x plus 9 equals, and when you're squaring something or raising it to its index power, it just becomes the radicand. And then you integrate. So we bring the 4 over, it becomes a negative 10x. We bring the negative 12 over, it becomes a 21. We now factor that. X, 7, 3 minus minus. So x here is 3, x here is 7. Now what you would have to do is put each of these in the original formula and see if they are in fact an answer. It may be that one of these doesn't work. So in your answer column, you have to pick that out. Again, I'm showing you the technique. We are going to be dealing with the letter I, imaginary numbers. So what would this be? Well, the first step is you take out the square root of negative 1. And then you get the square root of 45, which is the square root of 9, times the square root of 5. So our I is the square root of negative 1. So we get 3I, the square root of 5, for this answer. And here, when the I appears in a string of terms, it's just like it was a variable. Here, this will become a plus here. This will become a negative, and this will become a negative, and just add your items. Now, when we do something like number 27, we have to say this is 4I times 3I. We can't just multiply these together. We have to do it this way. So this then becomes 12I squared. And we have to remember that I squared is a negative 1. So negative 1, we never leave an answer with I squared. We always convert it to a negative 1. So this becomes a negative 12. And here we're just expanding that binomial. 4 squared is 16, minus this, double it, 8I, and then this will be plus I squared. And we said I squared is a negative 1 that we now can combine with 16. So we get 15 minus 8I, and that is in standard form. Here you would, I don't recall now whether we did these, they were there. We have to use the imaginary conjugates, which would be 4 plus 5I, 4 plus 5I. It's sort of like rationalizing the denominators. And then when we do this on the bottom here, this will be, since they're conjugates, no middle terms, 4 times 4 is 16. Then we get a negative 25I squared. But I squared is what? I squared is negative 1. So this becomes then a positive 25. So our denominator now is going to be 41. And then when we FOIL this, we have to put it in that particular form. Okay, the last thing, and I know you're going to have one like this on your final, it's powers of I. Well, remember, we said that anytime you have I to the 4th, that is going to be a positive 1. So how many I to the fourths do we have here? Well, we have I to the fourth to the 4 times 7 is 28. So this is I to the 28th right here, which is going to be a 1, because this is 1 to the 7th is 1, and you have one I left over. So for number 30, the answer is I. Okay, I'm going to keep this to 30 minutes, and it's just a tad over.